Okay, that's me, quantitative learning specialist. You know, I thought it was just a math teacher, but when you work at higher education, you got to have a fancy title. So, quantitative. That means numbers are going to be involved. Plain and simple. That's all it means. Quantities, you know, numbers only do one thing. All of mathematics literally only does one thing. It counts. Count, count, count. 1, 2, 3. That's all math is. That's all numbers do. And this is such a nebulous field, I really didn't know where to start. So I picked out what I feel are the most common questions that we get at the tutoring center. So besides myself, we do normally have a handful of very gifted stats tutors. We try to get a good representation from each program. Since most people are in the CSPP, we try to get the CSPP stats tutors. They were like XTAs. They know what's going on. They can help you with practically any kind of test that you need to do. They're also really, really good with the decision tree. Which test should you use? Okay. So I decided to start with the big three. So whenever you're running any kind of statistical analysis, three things you got to know, right? What exactly is it you're going to measure? How exactly are you going to measure it? And which test are you going to run? Okay? What are you going to do? How are you going to measure it? Which test are you going to use? So let's go over what are you going to measure. Every semester, I get a couple of people come in, and they've gone through a lot of work, and they've made this survey, and they're trying to measure how happy a person is, or how successful a person is. So I just right off the bat, number one, there's some things you cannot measure. Okay? Because what scales for happiness for me is different for you, right? I'm very easily made happy. Remote control, nachos, I'm on cloud 9. Okay? Religiousness, happiness, success, other things that are just they're different from person to person. Okay? Stick with stuff that you can accurately measure. So how are you going to measure it? Survey. How many of you guys here plan on making a survey? Survey, survey, survey. There's a whole science to survey making by itself. I'll say that again. There's an entire class at this campus that teaches you how to make an accurate survey. So I'm going to give you some tips. If the better the survey, the easier it will be for your statistical analyses. Okay? So I just hit the wrong button. Scott, I'm blaming you.
Black, bottom right button.
Bottom right button. Thank you. Boom. Okay, so if you're not going to write a survey, you can get archival data. There's a few teachers here that are farming out some old MMPI data. I don't know where they're getting it from, but all the names have been deleted. So I guess we're not breaking any FERPA rules. I don't know what's going on. But archival data is perfectly good. It's perfectly legitimate. Okay? So back to the survey. You guys like these little float in and float out things? She'd never seen them before. She was like playing with it like a little video game for the longest time. So, all right. So for the surveys, use Qualtrics. Is anybody here not familiar with Qualtrics? Okay, Qualtrics, free to Alliance students. Scott has it on the library. Okay, email me, email Scott. We'll send you the link with the instructions. It's not exactly the most user-friendly software until you've used it a couple of times, okay? But once you've done it a couple of times, it is a great tool. You can download the data. You can send the link out to anybody you want. It adapts to mobile devices.
So does Qualtrics, then, can you use SPSS for if you put your information in Qualtrics?
The question was, can you use SPSS when you're using Qualtrics? Yes, you can. You have the option to download your results either in an Excel spreadsheet, SPSS, data file, any kind of other data file. It's a really cool, it's an amazing tool. Qualtrics is free for Alliance students. It's not free from other students. There are other ones out there. SurveyMonkey? Is that still free?
No.
The 10 questions.
Yeah.
10
questions, but I've paid for it, so I know that it's not free.
It's not free. It used to be free in the old days. When I first came out, it was free, and I thought it was pretty cool. So.
But it's no Qualtrics.
Yeah, but it's no Qualtrics. Qualtrics is, man, it does everything. It will make waffles for you, so not really. Okay, how are you going to measure it? How many of you guys don't know what a Likert scale is? Good. Likert scale is a scale with numbers that basically try to gauge, try to measure a specific characteristic or somebody. So what happens a lot is people will reverse the order. They will put 1 meaning I love this, and 5 or 7 or 9. A Likert scale should be odd. You know, most of us use 1 to 5. That's fine. Okay. If you're not getting the variance you want, you should make it 1 to 7. 1 to 9. The bigger, the wider the scale, the more variance you'll be able to recognize, and that's what your tests will be using. It's going to be looking at the variance between the responses. So make your Likert scale, just make it look like this. The lower the number, the least characteristic. The higher the number, the higher the characteristic. Okay, so if somebody is a 4.5 out of 5 on how much I like chocolate cake, it's obvious. The guy likes chocolate cake. So what I see too frequently is it's backwards. So if I like chocolate cake, I'm going to make it a 1. But when you graph that data, like in a bar chart or something, the data is inversed. So the taller the spikes, that means the less they like it. So just remember, okay, the higher the number in Likert scales, the stronger the characteristic. That's fixable, by the way. Reverse coding. So if you do accidentally put it like that, we just reverse code it. Surveys again. If you make your own survey, how many of you guys plan on making your own survey? Okay. A good survey shouldn't be too long. If it's too long, people are going to start it, they're not going to finish it. If they don't finish the data, you usually don't use that person in your survey. So keep it short and to the point. I know sometimes it's hard. But, you know, anywhere around 10 minutes, 15 minutes should be maximum time to answer a survey. Everything that you're trying to measure, you should have at least 3 separate questions measuring the same thing. Word them differently to make sure they're paying attention. When you write your own survey, you're going to have to run what we call a factor analysis on it. So let's go back to those 3 questions. If I was afraid of sharks, and there are 3 questions where they all were measuring my fear of sharks, they should all be 5 out of 5. Okay? That's what factor analysis does. It checks to make sure that your questions are measuring the same thing. That's reliability. Validity is something completely different. Okay? There's literally 50 different kinds of validity. Okay? Internal validity, external validity, face validity, yeah, it goes on and on. There's only 2 in statistics that we use that are mathematically based. Convergent validity, discriminant validity. So you're going to have to do that as well, okay, mathematically. Unless, if you use somebody else's survey, right, from one of these millions of papers, quote what they did. Quote their reliability and their validity. That way you're done. You don't, if somebody else already did it, you don't have to do it again. Right? So far, so good? Anything?
Well, I have a question.
Yeah.
So, to check the reliability and validity, how many people need to take it in order to say that, yes, this is statistically reliable and valid?
See, that's a good question. He brought up is the sample size. What is the minimum sample size that you're going to need to ensure reliability and the validity of the data? that's just it. With surveys, it kind of depends which kind of test you're running. We have a rule of thumb that if you're going to run a multiple regression model, you should have at least 10 people per variable. Minimum of 10 people per variable. So when it comes to sample size, you're going to do a power analysis once you know which test you're going to run. It's called an a priori power analysis, and it's going to give you the minimum sample size. Okay? How many of you guys did a factor analysis? One.
That's a personal question, Richard.
No.
Okay, factor analysis, it's not that hard. Believe me, it's not that hard, you know. I'm going to show you resources that got video tutorials on how to do all of this stuff. Okay? Boom. Right, discriminant convergent validity. And, okay, a lot of this has to go back to your board and your chairs, right? I don't know if I should say this. So, since I'm editing the video, I might be able to take it out. But a lot of it depends on the skill levels of your board and chairs, right? How well do they know statistics? Plain and simple, right? If they're expert in statistics, then your statistics has to be bulletproof. If they're not expert at statistics, your stuff should still be sound and logical, okay? But there's a lot of leeway in there, okay? Moving on.
We have a question.
Yeah.
Any good resources for power analysis?
Yes. Moving on. It's a slide coming up here in a second. Boom. Which analysis? Okay, this, forget it. Boom. Which test are you going to use? There are over 100 statistical tests to use. There's stuff out there called decision trees. Just confusing as heck. They're not trees per se. They look more like seaweed farms. They're just all over the place. But when it comes down to which test you're going to use, it really there's only two things that are going to decide which test you're going to use. Which is, it's the types of variables you have, first of all. Are your variables regular continuous variables? In other words, you know, is 7.2 higher than 4.3? That's called a scale, ratio, continuous. Goes on by many. They're just numbers. That's all it is, regular numbers. Is it a categorical variable? Right? Blue car, green car, red car, where a number doesn't make any sense. Everything is in a category. And then the last one is ordinal. Order, right? Order and ratio are relatively the same thing, right? Is a 4 higher than a 2? That's an ordinal. And that's interchangeable almost all the time with ratio, okay? But once you know what your variables are, the second part is, what's your question? Are you looking for a difference? Or are you looking for a relation? Are you looking for a difference, or are you looking for a relation? And between difference and relation, that's practically everything you're going to do in statistics, not counting the charts and graphs. Charts and graphs is descriptives, okay? This is inferential. These are your analyses, your ANOVAs, and your regressions. You're either looking for a difference, or you're looking for a relationship. That's it. So when you're talking to somebody on your board and you hear the word difference come out of your mouth, you're going to use one of the difference tests. Or if you're going to hear a cause and effect, that's a relationship. Relationship. Those are going to be correlational models. So for differences, you're going to use differences between the means, by the way, the group means. T-tests. Anybody know how many different t-tests there are? Wait a minute.
Well, there's planned comparison t-tests and like all sorts.
Well, I'll give you extra credit for that. There's 3 tests, 3 t-tests. Leave. Number 1 test you're going to use, t-test, is the independent 2-sample t-test. Right? Somebody who's in group A is not in group B. Second most common is a paired t-test. It's a pre and a post, right? The same people took the first test, same people took the second test. That's a paired t-test. Last one is a dependent single sample t-test, where you take a subgroup and you compare it to a larger population. That's a dependent one sample t-test. So those are the big three. So, but that t-test is for two groups. What do you use if you got more than two groups?
An ANOVA.
An ANOVA, analysis of variance. It's built on the t-test. The t-test is the grandfather of all statistical analyses. I'll say that again. Everything done in statistics started with a t-test. That's why they're so important. Okay? So now when you get into more than two groups, that's when the statistical caca hits the fan. That's when everything gets so complicated, okay? Because there's a ton of different ANOVAs. There's a between group ANOVA, a within group ANOVA. There's a factorial ANOVA, which means you got more than one IV. There's a mixed ANOVA, which means that at least one of your IV is a within group or a repeated measure, and the other ones are not. They're between group. There's a MANOVA. Anybody know the difference between a MANOVA and an ANOVA? More DVs. ANOVA only has one DV. A MANOVA has multiple DVs. ANCOVA. Anybody? Where did the C come from? What's the C stand for? Covariate. Covariate. What's a covariate?
Mediating variable.
Yeah, it's a mediating variable. More extra credit for you. Boom.
I expect an individual on my dissertation.
You're getting there. You're getting there. Nested design, plan comparisons. It goes on and on and on. With ANOVAs, there's literally 12, 15 different kind of ANOVAs, and they all have a different set of assumptions. That's the killer, right? They all have their own set of assumptions. They all have their own different post hoc tests you're supposed to use, and the effect size and the power. So whenever you run any kind of statistical analysis, you're actually looking for three outcomes. Three outcomes for any test. Was it significant? Okay? If it wasn't significant, stop. You're done. You don't care if it didn't have effect size or power. But if it is significant, you have to look at the effect size. The effect size is what percent of the variance you can explain. Say that again. Effect size is how much of the variance you can explain, what percent you can explain. We want a large effect size. Because you can have a significant, but if you got a small effect size, then that means your study is big deal. You can explain 5% of the results. That's nothing to write home about. The last one is power. Power measures the sensitivity of your test. In other words, how accurate is your test measuring what you think you're measuring? Power has a lot to do with sample size. But three things: significance, effect size, power. Me. If I start losing my throat, I'm going to let Courtney take over. Time.
12:25.
Boom. Good, move along. Relations between variables. Okay? Cause and effect. Starts with correlations. Correlations are built on t-tests, but all regression models are built on correlations. But which kind of correlation? There's Pearson, which is the main one you're going to use, right? Little sidebar, I don't know if you knew this. Pearson was a eugenist. He believed in perfection of the human race. And he invented the correlation, statistics correlation, to perfect the human race. So this is back in the 30s and the 40s. He was a friend of Hitler, okay? And some of the other guys, like Kendall and Spearman, who used to be his students, disavowed him because he was such a creep. But it was his correlation that got all this stuff started. So, okay, there's three, right? Pearson, Spearman's, Kendall's. Point by serial, don't ever use that. Canonical, okay? Correlations are the foundations of regressions. And guess what? There's another 15 different kinds of regression models, right? Simple, multiple, hierarchical, stepwise, logistical, path analysis, structural equation modeling. This one right here is the hardest one that I know. Okay, it has confirmatory factor analysis in there. It has all these goodness of model fits. This is what we call the theory killer, SEM. But you got to be careful, because there's probably 2 people on this campus that could understand it professor-wise. So if your professor doesn't understand the test study, you make sure that they know what you're going to do. Again, I'll say that again. Make sure you communicate everything with your chair and your board when it comes to which statistical analysis you're going to use. Okay? Make sure they know it. So you don't want to surprise them or anything, because they're the ones that are going to have to pass or fail you. So with regressions, you should look for moderators and mediators. It strengthens your model, right? If you can explain more of what the variables are doing, it makes your model look better. Assumptions, effect size, power, same. And then you have your non-parametric relations, your chi-squared test. It has 2, test of independence, the goodness of fit test, and these are non-parametric. So non-parametric test, you can use that if your data isn't normal, if it violates some of the assumptions. You switch to the non-parametric version, and again, there's about a dozen of them. They're not as powerful as the parametric tests. But what makes a non-parametric test is instead of using the means, they use the medians, and instead of using standard deviations, they use counts. Research questions. All right, now, research questions come in 2 forms. A research question in itself can be, it can be very generalized, right? The hypotheses, they have to be real fine. You have to pick what you're going to say when it comes to hypotheses. Okay, let me give you an example. Research question, how does yoga affect depression? Right? For me, when I try to do yoga, it really increases my depression. I know it doesn't, me too. Okay, boom. On a hypothesis, you have to be exact, right? Hypothesis alternative. There will be a significant negative correlation between time spent practicing yoga and levels of depression, right? You got to be exact. You got to pick a side. So the more yoga, the less depression. That is a research question. So here's another example. There will be a significant difference in the mean depression scores between participants who practice yoga and those who do not. Does anybody know which kind of test you would run here? What word did you use? Difference, right? You're going to use a t-test or an ANOVA. Let's back it up. Well, it kind of gives it away, huh? Correlation. You could have put the word relationship in there, right? Right? Relation is in the word correlation. So, boom. All right, power analysis. At this stage in the game, power analysis, all you got to know is there's a formula. Actually, it's more like an idea. But power is the relationship between the sample size times the effect size on top. That's a top of a fraction. So power equals sample size times effect size divided by error. Error is what we call variance we cannot explain. It's within group variance. Within group variance is called error. We cannot explain the variance. So in a nutshell, at this point in time, if your power is not 0.8 or above, you will suffer. Okay? The cutoff that we use for power, acceptable power, is 0.8 and above. So, and a lot of times, and SPSS will spit out your power for you. It'll tell you your power. So let's say you get a power of 0.6. There are a few tricks. I hope I don't get in trouble for this, but there's a few tricks to increase your power. One is to increase your sample size. That's about the only thing you can really do. If you go out and get more people to be in your study, you can increase your sample size. That should increase your power. Your effect size, there's nothing you can do about that. The data will calculate the effect size. There are some tricks with reducing error. That's when you would change a regular ANOVA into like a nested design, something like that, where you're actually trying to whittle down the variance that you cannot explain. But that's 3 ways to increase power.
Can we also use a GPower analysis to really
And GPower, thank you, Scott, yes. So the way, I'm going to tell you guys, GPower is free. It's put out by a school in Germany. I suggest you go to their website. They have a nice little page in English for all us English speakers, but it's a free download. Be careful when you download. Don't click anything else, because a lot of these other things try to get you to change your toolbars or something. But just yeah, and play around with it. Okay. I'm getting pretty good at it. Once you practice it, it gets easier and easier. But it will tell you, you tell it which test, like how many groups, what kind of tests, what kind of relationships you're looking for, and it'll spit out a minimum sample size. Yeah, that's called GPower. It's free. And most people in their dissertations, that's what they say these days. They say, you ran a priori power analysis using GPower software, and it said this. And then you can cut and paste this and put it in your appendices. Okay? So they can see.
Somebody wants to know what the website is to access that, of the school, to download it.
Check Google.
Yeah, Google.
Just type in free GPower. But go to the one with the German school. It's a German... Deutsch. Ich spreche kleine Deutsch. All right. Power. Time.
12:33.
I suggest you get started with Excel. Once you get real data, use Excel. Excel is so much easier to use. Use Excel to clean your data first. Order your data. Label your data. It's just so much faster in Excel. Once you do that, you can cut and paste it easily into SPSS. It goes right into SPSS. All you got to do is cut and paste. Okay? So that's what I always do. I always clean it up in Excel first. Once I'm done with it, I put it in SPSS. We are currently using version 23. There is an online version, you guys. Just started again. We tried it a year ago. Didn't work out. Tried it again. It's working out. So we have a free online version, 23, for Alliance students with issues.
Did you download from home?
Actually, you never download anything. It's purely online. Okay? I'm going to walk you through this. And it doesn't have Amos. Amos is the software that does path analysis and structured equation modeling. I'm still trying to figure out why. It's such a rarely used thing that they didn't buy it. I don't know what's going on. But this is where you go. That sure does. Does it all. The online version, 23, does everything you will need to know. Some of the guys bought a student SPSS version, and it's missing important stuff.
Number 24, don't get it.
Yeah, version 24, student version. It's missing MANOVAs and MANCOVAs. It's missing all that stuff. So,
Throwing money away.
yeah, man. All right, so if you want a version, contact just tell them that you're on version. It takes about 2 minutes. Somebody will enroll you, send you the link, saying, okay, you're good to go. There is one issue. Because it's a cloud server program, it's not easy to open up a file from your computer onto the cloud computer. But I made a little video tutorial on how to do that. And I'm going to show you where it is here in a second. Time.
12:36.
All right, online statistical resources. Okay. The higher achievement, wisdom, and knowledge. The Hawk Moodles. We've been calling them that for about 10 years now. I like Hawks. It sounds cool. Okay? So our Hawk Moodles, hundreds of video tutorials, self-enrolling, accurate, comprehensive, and in fact, every one of them is a complete course with about 100 video tutorials. I had guided homework in there with the answers with video tutorials. Just about anything you want. So Hawk 1 is introductory stats, which is what you should know before you start advanced stats. I tried with these programs. Yeah, you guys laugh. I tried with every program. I figured the problem people were struggling in advanced stats is because they didn't know their beginning stats. And it's true. I mean, most of you guys haven't seen it in years. Right? What's a p-value?
It's at the back of the book, Richard.
If you're not fluent in p-values and standardized z-scores and standard deviations, you're going to get your head handed to you. Right? They don't even go over that in advanced stats. So everything you should know about advanced stats is in Hawk 1. Hawk 2 is differences. That's all your t-tests, your ANOVAs, your ANCOVAs, your MANCOVAs. And I'm going to show you one real quick. Hawk 3 is relationships. Those are your regressions, your correlations, your multiple regressions, your factor analysis, anything to do with a correlation. Hawk 4 is student-made comp reviews. That's just for the CSPP guys, okay? But we have a lot of sharp tutors here. They put a lot of great stuff together for anybody who's got to take a comp exam. Last one is dissertation support. Huzzah! So the videos that we make here, anything we cut from here, I'm going to just dump it in there. So hold on to that question. I'm going to show you this stuff.
Can you go back, I'm sorry, to the Hawks?
Hawk. Now, I'm going to show you how to reach them from the Alliant website. Let me know when you got it. No questions?
No, we're good.
I need a jog. Okay, here we go. All right, so let's go to the intranet. Dun, 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 dun. All right, so I don't know if I logged in or not. I'm going to log in. So this is the front page to our Moodle. I'm going to log in. Shkabam. Pay no attention to the stuff on the left here, you guys. I have God permission, so I get everybody's stuff. But from you're going to get this right here. Quick links. Look at that. Academic support and tutoring. You're going to click on that. But you guys didn't even know it was there. It's on the front page of the Alliant portal. But here's tutoring. Online academic. Online writing resources. We might as well tell you now, we got an online writing service now. Okay? So you guys are looking for online tutoring. We now have it available. Either real-time, online, where they have your paper and you're looking at your same paper and they do all that crazy stuff, or a 24-hour turnaround. You submit it, they put the feedback in it, they send it back, and it's free to you guys. We want you to use it, okay? So here's everything about stats. Here's all the Hawks again. Right? That's on the front page. Rules and regulations, read them. Number 1, don't use your damn cell phone when you're tutoring. Okay, tutoring appointments. You can make an online tutoring appointment here in San Diego. Okay? You want to see a writing tutor or a stats tutor? Go to the link. We'll show you how to do this. Here's the SPSS online. And it's got a little video on how to use it for the first time. Again, it's not user-friendly the first time. But I got about 1 million. I'm YouTube famous, you guys. I am. Me too. How come it's not playing? I don't know. Yeah, you're going to get sick of the guy talking. I tell you, he makes me crazy. And then this has been here forever, but nobody uses it. It's called the Statistics Dictionary. It's a video dictionary of every statistical term I can think of. So, and it's got videos. I got all these explanations. Oh, there's the talking head one. That one made me famous. ANCOVAs. And I got links back to the Hawks where they have more stuff in them. Let's go back to the Hawk and look at an ANCOVA. And you got to log in. And I think we're moving from Moodle here shortly, so this might be easier to get to. That's the one thing I'm not crazy about, is you guys have to enroll. If you're not enlisted, if I haven't enrolled you in a Hawk, you have to self-enroll, which is not a big deal. I'll show you how in a second. But like the links from the dictionary go here. So let's look at an ANCOVA. Where are you? ANCOVA, ANCOVA. What it is, what's a covariate, how to find a true ANCOVA, assumptions, repeated measures, except blah, 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 blah. So I even have I have data sheets, I have examples where you could follow along, right? I got the videos somewhere, but it's all right there in front of you. So if you're not on the Moodle, go to the Moodle page, Home 1, scroll down to the very bottom. There's a little tiny search box. Just simply type in Hawk, and anything with Hawk in the name will show up. Okay? So all 5 Hawks will show up, and we do have a writing center Hawk now. You guys know that? Turnitin.com. You can use it through the Hawk Tutoring Center. Right? Check the plagiarism before your teacher does. And there's a couple other free things in there that we're kind of proud of. So, but again, just check it out. Chemistry and, for the undergraduate classes. How we doing? Time?
12:43.
All right. So questions. Let's hit it. Questions. Who's got a question? Mark, question.
If you're considering using a mixed method study, quantitative and qualitative, is there any quantitative methods that would fit better with a mixed method?
You can do both a regression model and an ANOVA with a mixed method. Yeah, so a mixed method ANOVA would be between groups. That means one of your variables is categorical. Oh, sorry. Sorry, one of the person in the audience was asking about if you had mixed methods, and by that I think he means different types of variables by categorical variables and ratio variable, or just regular number scale variables. Is that what you were asking?
No, actually, I'm talking about combining quantitative and qualitative.
Okay, rephrasing. He wants to mix both qualitative and quantitative, which a lot of people do. I mean, right? You could do that. A lot of people do both of those. The only thing I can think of is probably make sure your chair and board members are aware of what you're doing, okay? Because that qualitative part can really swell. I mean, a good qualitative report that I've ever seen has, 200, 300 pages by itself, where a quantitative, usually your quantitative dissertations are a lot shorter because they're all fact-based, they're all empirically driven, and the other ones are, are not. They're just like long book reports. So, but yeah, check with your chair first to make sure they're happy.
We have a question. Is it true that for multiple regression and moderating regression, there are no methods for estimating power? So can estimate power for an effect of one independent variable, but not for the interaction?
I'm not sure I understand the question.
Well, it seems like a two-part question. First, is it true that for multiple regression and moderating regression, there are no methods for estimating power?
No, that's not true. You can get the power from a regression model. Is that the question?
Yes, I think so.
But is she talking about the influence of a single variable on the outcome?
It looks like it.
Okay, so it sounds to me like you're confusing power with what we call partial correlations or semi-partial correlations. That will give you the influence of each individual variable in a prediction model. I hope that helped. Yes, Ines.
What is the link to the video and slides for the research for qualitative?
How long is the video for qualitative? I believe it's like an hour and a half.
No, what is the link? You said you would share the link.
Oh, the link.
Yeah.
Oh. I will show you the link. The link is in Hawk 5. Somewhere. Let's see, Hawk 5, that comes after 4. Yeah, I found all these funny things online. They should put a smile on your face. So what Scott did, this was an old one. Okay, library research, he did this one about 5 or 6 or 7 years ago. And I did put a lot of stat stuff on here, quantitative methodology, dissertation, blah, 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 blah. There it is, qualitative, topic 5. There's the link right there, qualitative review by Dr. Miller. Yeah, and yeah, 97 minutes. But she's very, very thorough, very thorough. All right.
Thank you.
You're welcome.
So, in your dissertation proposal, when in your methodology section, do you have to list out all the different tests you are using based on whether it's based on your variables in your research questions?
Okay, so his question was, in your proposal, do you have to list out every test that you're planning on using? I don't think so. Because, you know, in your proposal, so let's go back to yoga, right? How does yoga affect depression models? You could do that with a t-test, an ANOVA, with a regression model, chi-squared model. There's just every kind of test in the world can be applied depending on how you want to approach it, right? You collect data. You have the option of changing data variables. You could change variables from like a scored variable, right? Like a ratio variable. You could turn it into a categorical variable, right? If you had like a score from 1 to 100, you could make like 1 to 30 low, 30 to 70 medium, anything above 70 high. So you basically just changed a ratio variable into a categorical variable, which then gives you different options on which tested you want that you want to use. So no, I don't think during the original proposal you have to put in which test that you're going to use.
Okay.
I guess. I'm not sure. Everybody's different. Yes.
So my dissertation will likely be a project-based kind of dissertation rather than a traditional one. So how does statistics fit into that? Where are the
Project. Okay, she's talking about. She's probably going to be working on a project-based dissertation. So, is there data being collected?
Probably yes.
All right. So, if there's data being collected, then that means there's going to be some kind of statistical analysis in it, right?
Okay. But so there are potentially project-based ones where statistics are just not collected and it's only in the lit review?
Well, okay. What I've seen is I did help somebody with a qualitative study once, and I found it very interesting because she had interviewed like 70 people. But after the 12th or 13th person, you start seeing patterns. These people are saying the same thing. So once, and that's a qualitative thing. Once you start seeing a pattern in repeated answers, that's when you stop, right? You found the underlying thing, something like that. But that doesn't really have anything to do with numbers, okay? But if there's numbers involved, that means empirical proof, which means statistics. So.
We have a question. Which is the best resource to use to ask someone about my variables and make sure I'm categorizing them correctly? And in order to pick the right test.
Besides me? Your chair. There should be somebody on your board that knows a little bit about statistics. Okay? But if you can't find that, email me. I've done it so many times. I'm actually really quick, really fast on telling you which test you should use. Or, a better way to say is this test will answer these questions. This test will answer these types of questions. So if you don't have anybody on your board that can help you, go ahead and email me, and I'll try to point it out as fast as humanly possible for you. Don't tell anybody.
She says thank you.
You're welcome. Anything?
So how about the idea of a priority? You know, when you're doing your method and you're doing your proposal, how would the a priority fit into what test you might want to use?
All right, that was Mitch in the back. Hi, Mitch. He's asking about where would where does an a priori go when it comes to your, statistical analyses. So a priori is simply Latin. It means before, right? So before you do any kind of analysis, what are you going to do beforehand? So after the test, that's called a post hoc, okay? So there's a lot of post hoc tests you can run, but when it comes to a priori, the only one I've ever heard is the power, to get the right sample size, an a priori power analysis. Because you don't want to go through all of this stuff and realize that you didn't have the right sample size. Okay, again, it comes back to significance, effect size, and power. You could have strong significance, strong effect size, but if your power's weak, boom, that just shoots you down big time. The professionals would laugh you out of the scholar club or something. So, but again, anything that you want to do beforehand to make sure that your research study is going to be robust, it's going to be valid, it's going to be reliable. Nobody will question your ways, okay? Because there are people out there that are just waiting to rip apart your study. You got to make sure you mention every assumption. Was it violated or not, right? You can violate a few assumptions and still continue. Okay, you just got to follow the big set of rules for statistics. Okay, so.
We have another one. Is a larger sample size required if using an interaction or a mediator moderator?
Yes.
Okay.
A good rule of thumb is the larger the sample size, the better. There's no such thing as too large of a sample size, right? You got to look at it this way. All of statistics, you're taking a sample from a population. You're trying to prove what you found is true in the sample can be said for the population. So the larger the sample, the more accurate the results. And if you think about it visually, think of the sample getting larger and larger and larger until it's the same size as the population. Okay? So the data you got from the population, they're no longer statistics, they're parameters, okay? There's nothing to test because if you ask everybody in that population, there's nothing to test. That is the answer, period, okay? So, again, statistics is trying to prove information from a sample can be transferred to the population. That's what we're trying to do there, so. Yes?
Are you or the tutorial or the tutors available to help out with dissertation in terms of the statistical test that needs to be run for your dissertation?
All right, there's the million-dollar question. He wants to know if I or my tutors can help with dissertation statistics. The official word is no. Okay. With that said, I will work with anybody for 1 hour. To make sure you guys are on the right track, okay? If I can hear your research questions, I can tell you what your variables better look like, which test you're going to use. I'll even run a power analysis to give you a minimum sample size, and just to make sure you're on the right track, okay? I will tell you which links you can use. Every test that you're going to run, I got videos on, and SPSS tutorials. In the old days, we had to do it by hand, okay? So if you got a teacher that doesn't like you and makes you do it by hand, we even have the on hand by hand covered, okay? So everything you're going to need to do for your dissertation, I have video tutorials on. So again, the short answer is I will meet with you for an hour. I will look at your data. I will identify your variables. I will tell you if they need fixing or not. I will recommend which test to run and where to get the resources to answer all those questions. And now when it comes to my tutors, we have a rule. If you mention the dissertation word, you come see me, and then I give you the same speech I just gave everybody else. But if you go in there and say, can you show me how to run an ANCOVE and SPSS? Don't mention the dissertation word. They will sit you down, and walk you through and COBA or something. If you've got your own data, that's fine too. They'll do it with your own data. Just don't mention the D word to the tutors, because I've already told them.
Should we say thesis instead?
Yeah, now, don't they say thesis like in England or Europe or something? Or
Librarians all use that.
thesis, yeah, I see that all the time. Thesis, dissertation, I mean...
It's like running in COBA from a thesis.
Yeah, that's pretty clever. Anything else? All right, we're going to call it. All right, I want to thank all of you guys again for showing up on a Saturday of all places. This place was very well attended, and so I want to thank you for everything. I got business cards up here if you need them. I'm all over the website. Again, go to the front page under tutoring. My name is right there, academic support and tutoring. I'm all over the place, and it's been a pleasure. You guys have a great weekend, and we'll talk soon. All right. Wait. With an addendum?
The Quantitative survey, you want to learn to improve?
Oh, yeah. I'm going to send everybody out a Qualtrics survey to try to figure out what you guys liked here, what you didn't like here. Again, we're going to try to get this thing on a regular basis. I'm trying to get a dissertation support center going on this campus. So, we had such a great turnout this time. I would just love to see a part of you guys' regimen, because you guys, I know how hard you work, right? I know how hard it is. So, but again, this is your baby. This is your magnum opus. Yes?
Let me just make one quick suggestion.
Yeah.
We've gone through the whole program for so long. I think it would be nice to have this at the beginning of the program, so students kind of have an idea of what to expect as part of the dissertation versus towards the end of the program.
I second that.
If you guys think like maybe even go into one of the dissertation courses, or dissertation 1, 2, or even 3, just to kind of give a 10-minute spiel of, kind of some of what you guys did today, that'd be awesome.
See, part of the issue is there's different programs, right? See, we're the tutoring department. I mean, we're just a little nobody. We're over there in a trailer with, and then every program's different. Every program sets up their own instructions. Which program are you in? Leadership.
So we're in business. I would say 85–90% of what you have had throughout this course or this time period is relevant. I've been saying for years, you need a class like this up front. So before you start researching papers and et cetera, you could be actually constructing your presentation
as you go.
Yes, sir.
Right. So these guys are saying that we should have this kind of meeting, this kind of class, in the first semester when you come to this school, right? To give you guidance and direction, et cetera, et cetera.
The first week of the fall semester and the spring semester, and you're just supposed to show up as an extracurricular thing. Like, even if it was announced, like, everybody needs to come to this. Like, I just think coordinating with the programs is so hard that just offering it every semester might be the answer, because, like, I came in April, and it was, like, off track, and then I never had orientation on anything, much less I just kind of figured it all out.
Yeah, I'm a big believer, right? I mean, you guys.
Like all the library stuff Scott was showing us, I figured it all out, but it's taking hours and hours and hours to do that on my own, just kind of plunking through. That would be great thing to see.
Correct, I agree.
Even the Hawk, not having that just, somehow told to me ahead of time.
Number one complaint is they don't even know it's there. So what I try to do is I go through the teacher list and I pull out all the stats teachers, research design, anybody that teaches anything with stats. There's about 30 of them. And I send them everything and I say, can you put this in your syllabus and make sure everybody knows about it? And half of them love it. They think it's the greatest thing since sliced bread. The other half I'd never even hear from before. But yeah, we do have a ton of resources already out there. And if it was up to me, I would start this out, okay? Not the first week, but probably the second week, third week, after the shock wears off, right? Then you come in and we have a nice little friendly get-together. And
when I brought up this question, it was, well, just ask me and we'll tell you. And I'm like, I don't know what I don't know.
Right.
Right. We don't know what we don't know, right? So I agree. Now, you guys are a voice now, okay? This will go to the right people. You need to speak to your professors, speak to your program directors about what a wonderful program this was and how wonderful the people who put it on were. And we we want to make this a regular thing for everybody. Okay, we want to make your lives easier because we know that writing a dissertation is hard. Period. Okay, it's your magnum opus.
Success rate will go.
Yeah, good. Boom.
One more question
Scott,
about
sir.
SPSS online.
Yes.
I got back from IT that I can use it only when I'm a member of group SPS that's remote. So log in that way.
Sounds like a new video tutorial for me. I'll get to the bottom of it.
Okay.
It used to be somebody would enroll you, they would send you the links, and then once you get there, you have to. One of the things you have to click is some kind of remote thing, but that's in the tutorial video, which is on
I just want to make you aware.
webpage. I'll straighten them out. So, all right. Anybody? Last call for alcohol. All right, that's it. We'll call it. Thank you all for showing up. Yay! All right. Say goodbye to everybody.
All right. Goodbye, everyone.
Bye, everybody.